Hello geometry students, Mr. Gazzato, and today we want to take a look at pages 28 through 31 in our Unit 5 packet. And if you read the top of the page here on page 28, the learning target is to use the side splitter theorem and the triangle angle bisector theorem to find missing lengths of a triangle. So what I'd like you to do here is take a look at the screen and see if you notice anything. So notice the parallel lines. So the red marks mean the lines are parallel. That's one thing you should have noticed. And then the second thing, hopefully you start to look at, that if you look at 20 over 10, that is the same as 22 over 11. In the other other triangle, you might see that 4 over 12 reduces to 1 over 3, and 5 over 15 reduces to 1 over 3. So the idea here is the top part divided by the bottom part is equal to the top part divided by the bottom part. So if we go to our notes page here, what we just observed was A over B is equal to C over D in the triangle below. So I'm going to put like the top over the bottom. Those two proportions are equal. If we were to add the letter F here, and we were to add the letter E for the whole side, it actually turns out that A over E is equal to C over D. So you could say the top part to the whole, I'm going to call E the whole, and it even turns out that B over E is equal to D over F, meaning the bottom piece over the whole, which is E and F, are actually equal. And for clarity, I do want to mark that these two lines are parallel. So in today's examples, we're going to be solving for missing parts of the triangle. In the middle box here, again, these lines are parallel, so let's mark them parallel. And you could do the same type of thing, that x over y is equal to z over w. So the top piece over the bottom piece, those proportions are equal. If I were to add r and t, we could say x over r is equal to z over t. So the top piece to the whole are equal. And in fact, you could say y over r is equal to w over t, meaning the bottom piece over the whole are equal. And the third example here, this line that I'm highlighting in green is the angle bisector. So these two angles in red are equal. So we need to make sure that we know that that's the angle bisector. And if you consider that green line to be like the fraction bar, I could say m over k is equal to n over p. So that's another proportion that is equal as long as that green line is the angle bisector. Here's a quick visual representation of what I just talked about in terms of the angle bisector. You could see 6 divided by 8 is equal to 3 over 4, and that angle bisector I consider to be the fraction bar. If I were to drag point C, you still can see that those fractions are equal no matter what happens. So 6 over 4.52 is equal to 3.96 over 2.98 as long as you have an angle bisector. So let's look at the problems on page 28. In problem number 1, we want to find LS. So I'm going to label that X. And then using the theorem on the top left of our page, we could say 8 over 10 is equal to x over 15. So the top part to the bottom, so the top in yellow to the bottom, is equal to the top 8 over the bottom. And then we're going to cross multiply. 10x is equal to 8 times 15 is 120. Divide by 10. And we get x is equal to 12. In problem number 3, so I'm going to skip number 2 temporarily, we want to solve for bk. So I'll call bk, let's call it y this time. So the proportion I could set up is 1 over 4. So the top piece in 1 to the bottom piece 4 is equal to the top piece of 1 to y. And you probably can tell by inspection that y is equal to 4. Now notice in both problem 1 and 3, we were solving for one of the non-parallel sides. If you look at problem number 2, we want to solve for ML. So I'm going to highlight that in green. So I'm going to call that, let's call that X. The theorem that we just learned does not apply. But if I were to draw the two triangles separately, we have 15 and 18. I get 18 by doing 10 plus 8. And if I were to draw the little triangle, we have 8 and X. So now using similar triangles, we can set up some proportions. We could say 18 over 8 is equal to 15 over X. So I went the yellow over the yellow, and then divide by the 15 over the X. So now we can cross multiply. 18x is equal to 120. Divide by 18. And here you will get a decimal possibly. You get x to be 6.6 repeating. In problem number 4, it's a similar idea. In problem number 4, we are trying to solve for CB, which is one of the parallel sides. So what we learned we cannot apply, so I'm going to call that Y. And I'm going to draw the little triangle. We have 1 and 5. And I'm going to draw the big triangle. We have Y at the bottom, and then this side that I'm highlighting in green is 1 plus 4, so that piece is 5. So now I could set up the proportion 1 over 5, so that's the green 1 divided by the green 5, is equal to 5 over Y. It's the yellow 5 divided by the Y. So if we were to cross multiply, Y is equal to 25. So to summarize these 4 problems on page 28, the 2 problems on the left, you can use the theorem that we learned at the top of page 28, that the top piece over the bottom piece is equal to the top piece over the bottom piece. However, examples 2 and 4, you may not utilize the theorem because you're trying to find one of the parallel sides. So I personally separate the 2 triangles, set up the proportion, and solve. Let's go on to page 29 and look at some examples. So we look at problems 6 and 7. That's going to use the middle box that we took notes on. Again, these lines are assumed to be parallel, so I'm going to mark them parallel. The markings are a little off on the handout for problem number 6. And we can set up the proportion. So for problem 6, we could say the top piece of 2 divided by the bottom piece of 6 is equal to the top piece of x divided by the bottom piece of 8. So 2 over 6 is equal to x over 8. Then we can multiply. We get 6x equals 16. I highlighted those in blue and green. So 6x is equal to 16. And when you divide, again, you will get some decimals. 2.6 repeating. In problem number 7, we want to use the idea we have the whole piece is 15. So me personally on the left-hand side, I'm going to figure out this whole piece, which is going to be 3 plus 9, or excuse me, 3 plus 6, which is going to give me 9. So then I'm going to set up my proportions. So after I get that piece, I could set up my proportions. The top piece of 3 to the whole piece of 9 is equal to the top piece of x divided by the whole piece of 15. So that proportion was 3 over 9 is equal to x over 15. When you multiply, you get 9x is equal to 45. Divide by 9, x is equal to 5. So what I would like you to do is pause the screen and try problems 8 and 9, and when you are done, come back and check your answers. So let's see how you did. For problem number 8, it is stated that these lines are parallel, so we need the lines to be parallel. So to find x, I might say 10 over 15 is equal to 9 over x. So those are the corresponding proportions. So 10 over 15 is 9 over x. Multiplying, 10x is equal to 135. Divide by 10. Again, you will get a decimal, 13.5. For y, I still will use the 10, but this time I'm going to say 10 over 18 is equal to 9 over y. So they're in the kind of the same spot, so the proportion would be 10 over 18 is 9 over y. Again, when we multiply, we'll get 10y is equal to 162. Divide by 10, and we get y to be 16.2. For problem number 9, if you haven't paused the screen, please pause the screen and try that problem. Let's see how you did on number 9. So for number 9, I could say 2 over 6, the top over bottom, is equal to x over 12. So to find x, I'm going to write that proportion down. 2 over 6 is equal to x over 12. We'll get 6x is equal to 24 when you multiply, and then when you divide, you get x to be 4. Now to find y, you have to remember that y is the parallel side. So for finding y, I'm going to draw the little triangle, 2 and 5. I'm going to draw the big triangle, y, and I need to get this yellow side. That yellow side is 2 plus 6, which is 8. So to find one of the parallel sides, I separate the two triangles. So now I could say 2 over 8, the yellow piece divided by the yellow piece, is equal to 5 over y, which I highlighted in blue. Multiplying, we get 2y is equal to 40. Divide by 2. Y is equal to 20. So let's take a look at example 1 and 2 on the bottom of page 29. So the first thing I notice is this says our angle RVS is congruent to SVT, and we are missing the angle point R there. So these two blue angles are equal, which means this is the angle bisector. So I think of that green line as the fraction bar. So 8 divided by 10 is equal to 4 divided by x. So let me write that down. 8 divided by 10 equals 4 over x. Multiplying, 8x is equal to 40. Divide by 8. X is equal to 5. Now that we solve for x in problem number 1, we need to find ST. So ST is actually x. So ST is equal to 5. Let's take a look at example number 2. In example number 2, we want to find SR and RQ. You can see the angle bisector marks. So this blue line I think as the fraction bar. So I say 144 over 108 is equal to 7x over 5x plus 2. When we multiply, 108 times 7x is equal to 144. Make sure you include parentheses here. 5x plus 2. So 108 times 7 is 756x equals, make sure you distribute that 144 to both values. So 144 times 5, 720x plus 288. We'll subtract 720x from both sides. And we'll get 36x is equal to 288. Divide by 36. And when you do 288 divided by 36, you get x to be 8. Now, we're not done with this particular problem because we need to find ST and SR and RQ. So SR is 7 times 8, which is 56, and RQ is 5 times 8 plus 2, which is 42. Let's look at the problems on page 30. For example 3 and 4 on page 30, notice on example 3 you have the angles are marked as the angle bisectors. So again, this is the fraction bar. In this particular problem, let's call BDX, and then DC you can label as 14 minus x. And at this point, you can set up the fraction. So you can say 9 over 15 that I highlighted in yellow is equal to x over 14 minus x. So the proportions for number 3 are 9 over 15 is equal to x over 14 minus x. Multiplying, you get 15x is equal to 9 times 14 minus x. Distributing, so 9 times 14 is 126, so make sure you distribute the 9. So you get 126 minus 9x is equal to 15x. Let's add 9x to both sides. 24x is equal to 126. 126 divided by 24 is 5.25. Now, if you read the problem, we want to find BD. So BD is x, so the final answer here is BD is equal to 5.25. I want you to pause the screen and try problem number 4 and see how you did. So for problem number 4, this is the angle bisector again. So I think of that as my fraction bar. So x over 2 divided by 10 is equal to 32 over 40. So let me write that down. X minus 2 over 10 equals 32 over 40. Multiplying, 320 is equal to 40 times x minus 2. 320 is equal to, make sure you distribute properly, 40x minus 80. Let's add 80 to both sides. 400 is 40x. Divide by 40, and we get x to be 10. But for example number 4, we are asked for PS and SR. So PS is x minus 10, so 10 minus 2, which is 8. And then SR is 8 plus 10. Oops, SR is simply 10. So I don't think that was supposed to be there. But SR is equal to 10. So the next couple problems are practice problems. You can pause the video, try the problems, and when you come back, I will have the solutions on the screen for you. Okay, so for problem number 1, I have the whole side here in blue, x plus 12, so I need to figure out this whole side. 3 plus 9 is 12. Then I could set up the proportions. This bottom piece, 5, to the x plus 12 is equal to the 3 to the 12. So I'm going to set up this proportion. 5 over x plus 12 is equal to 3 over 12. So 60 is equal to 3 times x plus 12. Distribute. 3x plus 36. Take away 36. 24 is equal to 3x. divide by 3, x is equal to 8. For problem number 2, we can do the top piece to the bottom piece, so blue to yellow, is equal to the top piece, blue, to yellow. So the proportion we could set up is 3x plus 1 over 8 is equal to 5 over 4. 40 is equal to 4 times 3x plus 1. Distribute. 12x plus 4. Take away 4. 36 is equal to 12x. So x is equal to 3. I'm going to circle that answer so you see that highlighted. For problem number 3, we have this piece 4. We can calculate this yellow piece by doing 10 minus 4. So 10 minus 4 is 6. And at this point, now I could do the top piece, which is the yellow piece, to the whole. So I could do 6 over 10. And on the other side, it's going to be 9 over 5x. So the proportion for problem number 3 would be 6 over 10, the yellow to the green, is equal to 9 over 5x. Multiplying, you get 90 is equal to 30x. Divide by 30, x is equal to 3. When you look at problem number 4, you have the whole thing over here, 63. You have the whole thing over here, 28. You have the 10x minus 4, and you have the 16. So if you notice, those two proportions are in the same spot. So you can do yellow over green. So 10x minus 4 over 63 is 16 over 28. Multiplying, 63 times 16 is 1,008, is 28 times 10x minus 4. Let's distribute. 280x, distribute to 28 to both values. 28 times 4 is 112, so that's equal to 1,008. Let's add 112 to both sides. We'll get 1120 is 280x. Divide by 280. And when you do that on your calculator, you get x to be equal to 4. Let's go to the next page and see what we have. So we have problems 5, 6, 7, and 8. If you look at problem number 6, problem number 8, problem number 7, those are all using the angle bisector theorem that we learned. Problem number 5 is parallel lines. You can see there are parallel. Let's take a look at problem 5. So in problem number 5, we have the x plus 8 and we have the 25. So we have the 12, but I need this yellow piece. To get that yellow piece, I'm going to do 32 take away 12, so that yellow piece will be 20. Now I could set up my proportion green over yellow. So I could do x plus 8 over 25 is 12 over 20. Multiplying, 25 times 12 is 300, is 20 times x plus 8. 300 is equal to 20x plus 160. We'll subtract 160 from both sides. 140 is equal to 20x. Divide by 20. X is equal to 7. For problem number 6, we have the angle bisector, so this yellow line acts like the fraction bar. So we could say negative 8 plus 2x over 4 is equal to 10 over 5. So negative 8 plus 2x over 4 is equal to 10 over 5. I'm going to take some liberties here and simplify this to be 2. And then I'm going to put that over 1. It just makes the numbers a little smaller. So now when I multiply, I get 8 is equal to negative 8 plus 2x. We'll add 8 to both sides. 16 is equal to 2x. Divide by 2. And x is equal to 8. So this is the angle bisector theorem. For problem number 7, again, we have the angle bisector here. Now we need to find this little green piece here that I just highlighted. To find that green piece, we're going to do 14 take away 6, so that piece will be 8. And at this point now we could say the green to the blue is equal to the green piece to the blue piece. So that fraction we could set up as 8 over 6 is equal to 2x plus 2 over 12. When you multiply 8 and 12, you get 96. That's equal to 6 times 2x plus 2. We'll distribute. So 96 is equal to 12x plus 12. Take away 12 from both sides. You get 84 is equal to 12x. Divide each side by 12. And we get x to be 7. And here's our final example. Again, we have the angle bisector. That green is the angle bisector, so I like to say 4 over 2x minus 12 is equal to 10 over 5. I'm going to write that down. So 4 over 2x minus 12 is equal to 10 over 5. So I did yellow over blue. Multiplying, 20 is equal to 10 times 2x minus 12. Distribute, 20x minus 120. So distribute that 10. Let's add 120 to both sides. 140 is equal to 20x. Divide by 20. X is equal to 7. So these are the 3 theorems that we want you to know regarding triangles.